Hello and welcome to lesson 15-4. This is the last lesson, it's topic 15, and it is titled Make Sense and Persevere. So how do you make sense of a problem when you come across something you're not sure how to solve? And how do you persevere and keep trying to make sure that you're able to get to your answer? Let's go ahead and watch our video lesson and jump into our notes and guided practice after that.
How can you make sense of a problem and persevere in solving it? Think about this question during the lesson. On Aiden's farm, there are 12 acres of soybeans and 8 acres of corn. Aiden plans to replace his other crops with more acres of soybeans and corn. Will his farm ever have the same number of acres of soybeans and corn? Explain. You can make sense of the problem by answering these questions. What do you know? What are you asked to find? You know Aiden's farm has 12 acres of soybeans, and he plans on planting 3 more acres every year. It also has 8 acres of corn, and he plans on planting 4 more acres every year. You need to find whether his farm will ever have the same number of acres of soybeans and corn. Think, how can I make sense of and solve this problem? I can choose and implement an appropriate strategy, use ordered pairs to make graphs, identify and analyze patterns, check that my work and answer make sense. Here's my thinking. For each crop, I can write a rule, make a table, and plot the ordered pairs. Then I can see if the number of acres is ever the same. What is a rule for the number of acres of soybeans?
Select your answer.
For soybeans, use the rule start at 12 and add 3. For corn, use the rule start at 8 and add 4. Plot the ordered pairs and draw lines. After 2 years, will Aiden's farm have more acres of soybeans or corn? Explain how you know. After 2 years, Aiden's farm will have more acres of soybeans, since 18 acres is greater than 16 acres. Where the lines intersect, at 4 years, Aiden's farm has 24 acres of each crop.
Now you know how you can make sense of a problem and persevere in solving it.
All right, let's go ahead and get into our notes and our guided practice. So our focus question is, how can you make sense of a problem and persevere in solving it? So like we said, you can choose and apply an appropriate strategy. You can use ordered pairs to make a graph. You can identify and analyze the patterns that you see, and then you can check your work to see if your answers make sense. Our first example here says Val is planning a bowling and pizza party. Including herself, there will be no more than 10 guests. Val wonders which bowling alley offers the less expensive party plan. Complete the table below, and then on the same grid, graph the ordered pairs in each table. Use a different color for each of the values. Which bowling alley is less expensive and how do you know? So for Leonard's Lanes, they charge $25 plus $10 for each person. So you're starting at 25 and adding $10 for the first person. So your first guess is going to be 35. And then the next one, $10 more, 45. For the third guess, 55. For the fourth guess, 65, and so on until you get to 10 guests. For Southside Bowling, they charge just $15 per person. So your first guess is 15, your second guess is 30. For 3 guests, you pay 45. 4 guests, you pay 60. 5 guests, you pay 75. 6 guests, you pay 90, and so on. So when you're looking at the data here, you see there's a point where they overlap. At 5 guests for both of them, you would be paying $75. Now let's go ahead and plot our ordered pairs. So Leonard's, for 1, you would go 1, 35, 2, 45, 3, 55. So your number of guests is your x coordinate, and your cost is going to be your y coordinate for both. So we went ahead and plotted these points. So For your first, they charge a $25 flat fee, and then for the first guest, it's $10 more. So that's 135, 2 and 45, 3 and 55, 4 and 65, 5 and 75, 6 and 85, 7 and 95, 8, 105, 9, 115, and for 10 guests, it would be 125. Now for Southside Bowling, they don't charge you any flat rate, but for each guest, they charge you $15. So your first guest is at 1 and 15, your second point is at 230, your third point is at 345, then 460, 575 is here where those two lines crossed because that's where the data overlaps. 690, 7 105, 8 120, 9 135, and 10 150. So Leonard's Lanes is going to be our red line, and Southside Bowling is going to be our blue line. So if Val has fewer than 5 people, then she would be charged less. The least expensive option would be to go with Southside Bowling. But if she has 6 or more people, it would be less expensive for her to use Leonard's Lane. So you can see here where the graphs cross, one started lower and ended up higher, one started higher and ended up lower. Let's take a look at another example that's similar. It says O'Brien's Landscaping pays employees $15 plus $12 per lawn. Carter's Landscaping pays $25 plus $10 per lawn. Which company pays more? So we did O'Brien's in blue and we did Carter's in red. So O'Brien starts at 15, and then for one lawn, it's 15 plus 12, which is 27. For 2 lawns plus another 12, which is 39. For 3 lawns, it's 51. 4 lawns, it's 63. 5 is 75, and 6 is 87. For Carter's, they start at 25, and then they add $10 each time. So for 1 lawn, it's going to be $35. For 2, it's 45. For 3, it's 55. For 4, it's 65. 5 is 75, and 6 is 85. So see here, we have that same overlap that we had in the previous table where there's a point where both of them cross each other. And they both cross at 5 lawns where the employees would have each earned $75. Now, if I take those points and I plot them on my data table, or I plot them on my coordinate grid, I can see that they will cross at the 575 mark. But for Carter's, they will pay more if their employee is mowing 1 to 4 lawns, but O'Brien's will pay more if they're doing 6 or more lawns, and that the pay is the same for the 5 lawns. All right, let's look at our guided practice. It says Mindy's already saved $20 and plans to save $8 each month. Georgette has no money saved yet, but plans on saving $5 each month. Will the girls ever have the same amount of money? So our first question says, write a rule and complete each table. So Mindy's rule is start at 20 and then add 8. And Georgette's rule is start at 0 and add 5. So we set up our 2 data tables. And then we were going to graph the points. So Mindy starts at 20. So after one month, she saved 28. After 2 months, she saved 36. After 3 months, she saved 44, and so on. For Georgette, she started at 0. So after 1 month, she saved $5. After 2 months, she saved $10. After 3 months, she saved $15, and so on. Now we took those numbers and we plotted them into our graph as ordered pairs. So Mindy's was blue and Georgette's was red. So Mindy's, we started at 20. And then after 1 month, she had 28. And then 2 months was 36. 3 months was 44. 4 months is 52. 5 months is 60, and 6 months is 68. Georgette started at 0, and then she had $5 after 1 month, 10 after 2 months. For 3 months, she had 15. 4 months, she had 20. 5 months, she had 25, and 6 months, she had 30. Our next question asked us, will they ever have the same amount of money? So here, because they started at different points, and they're adding different amounts. So Georgette started with nothing, and she's adding a smaller amount. And Mindy started at $20 and she's adding a larger amount, they're never going to have the same amount of money. So as you extend that graph, they're going to be spread farther and farther apart. They're not going to be getting closer together. All right, that's the end of this video lesson. If you have any questions, let me know. Otherwise, have a great day. Bye-bye.